I'm going to be explaining the course revision quizzes for physics 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6. Okay, so let's start with 3.1. Question 1. Okay, whenever they want you to, the force symbol, you always do F of the first thing, which is the boy here, over the last thing, so door, or whatever the two objects are. Which one comes first is the first one, and whatever comes second is the second one. Okay, let's try it for the second one. Okay, and that's as you can see, that's our answer here. Okay, so first we write F. It's always F because force stands for F. F stands for force. What is the first thing? Object, whatever. A girl. So girl. And what's the second thing? Rope. So rope. So girl on rope. And then F of first thing, which is man. Second thing, which is a box. That's the action, so that doesn't count as a thing. This is also the action, it doesn't count, and this is an action. So F of the first thing, which is woman. Okay, this is the this is the force, or whatever the action, and this is the second thing. So sofa, this is the second object, and that's all of the answers. Okay, this is based on understanding and just common sense and the grids. Okay, so we know since grade 4, grade 2, whatever, the force is a push or pull, so that's the first one. And then this, for me, it was common sense, but this word that no one really thinks of it. Okay, so just memorize it or understand it. A force is a result of interaction, which is what do they do? They interact to make the force between two objects. Remember, it's two objects, not one, not two, not three, not four. Okay, it's always two. Okay, this question is technically the same thing for the first part. It's just they switched between pull and force. Like we said, a force is a push or a pull. So that's the answer for that part. And then a push or a pull. And if you didn't memorize it, here's it's the same question. Just they're giving you two different blanks. Okay, a push or a pull is a result of an interaction. That was the answer for the last question, between two objects. Like I said, it's not one or 3 or 4, it's 2. Okay, it's very simple, and that's section 3.1 done. Let's go to 3.2. Okay, this one you also have to memorize it. There's no explanation for this one. Okay, just need to remember gravity. We all know what gravity is. Electroweak, we're not supposed to know what the definition is for it till now. And then strong is the last one. Remember, they might trick you with magnetostrong. Magnetostrong, we have never heard of it. Strong is remember, they're giving us words for us. Okay, we don't know what magnetostrong is. We know what strong is. Okay, just think of it that way. We don't know any of these meanings for this one and this one. We don't know the meanings, but we just need to memorize them. Okay, now I don't know why a lot of people do mistakes in these, because they're pretty simple. Okay, whenever we see air, it's drag or air resistance. Okay, just remember that. Okay, this is resistance, with the pencil is so annoying. And then whenever we see earth on, that means it's weight. And then when we see cord, rope, or anything that you hang stuff on, it's tension. And then rough surface or surface, but it has to be rough, okay? Then it's friction, okay? Upthrust comes when you have water or a fluid, okay? Okay, here's upthrust. This will show you, okay? So tensional, we said when we have rope or cord or anything. Here's ropes, okay? So this is this one. So tension is that one. Okay. Frictional, like I said, surface or rough surface, okay? Here are surfaces, so that's one. Upthrust, like I said, water or fluid, and here we have fluid, so it's upthrust. And then normal force is whenever you see perpendicular, that means it's the normal force. Okay, that's it. Okay, here we have rough and surface. So when they're asking for the force and we have rough and surface, it's friction, like I said. And then where does this force act? They want, do you remember when I said something on something? So they want the first object, which is the cart here, so cart, on the last object, which is rough horizontal surface, so surface. Okay, and that's between the cart and the rough surface. If you remember the first object and the second object, you'll get all of these questions, okay? Okay. Here, they told you the friction is negligible, okay? That means we forget all about the friction. What else might stop the skier from descending down the slope? Okay, we would have said friction, okay? But in this question, they told us to forget about friction. Friction is negligible. Negligible means it's almost zero, okay? So we forget about it. What other thing can stop it? Air, right? So air resistance, or if they ask if the choices are drag and there's no air resistance, you pick drag because like I said, drag is the same thing as air resistance. Okay. First, to solve these types of questions, you need to know that action at a distance is between a distance. It's just common sense. You look at the word distance, that means it has a distance. Contact is when they're touching, okay? And let's solve the question. Okay, for action at a distance, the only ones we know are electrostatic, magnetic, and gravitational. These are the three and weight, okay? These are the three action at a distance forces, the four action at a distance forces, okay? And then the rest are contact, or if you don't want to memorize it, okay? Let's think of the contact forces. A force pushing the door. If you want to push a door, if you want to push anything, you'll have to touch it so you're able to touch it. So it's contact. So that's right. And then exerting a force means touching it. So it's contact. Force exerted by cable high, so it's exerted, so it's touching, so it's contact. Gravitational force, gravity. Can you touch gravity? No, so it's action at a distance. Magnetic. Do the magnets have to be touching so they can attract each other? No, so it's action at a distance. Electrostatic. Do you have to be touching electricity to get electrostatic energy? No, so it's action at a distance. And that's 3.2. Let's go 3.3. Okay, there's 3 questions only. Okay, we know forces. Okay, we know they have to have a magnitude, direction, and point of application. These are common sense questions. Okay, but if you don't want to have common sense or don't have common sense, you can memorize them. It's always magnitude, direction, and point of application. Source, you don't need to know the source of a force to, like, you don't have to know the source to characterize a force. You don't have to You don't have to like find the source, not force, to find the characteristics of a force. It's very confusing and the same thing, okay? And then we type. You don't need to know the type of a force to know the characteristics of it. Characteristics of a force are only three: magnitude, direction, and point of application. Okay, like I said, when we see on body by earth, so like earth on or by earth, it's always weight, okay? And it is known as the gravitational attraction of earth. Earth is pulling like a body down by gravity, which is weight. Okay? Okay. So in this question, it's also common sense. You have 1 equals 5, and then 2. From 1 to 2, you double it. So you have to also double the outcome. So 10. And that's it for 3.3. This also has 3 questions. Okay, see? If you didn't memorize that the force only has a magnitude, direction, application, this question will help you, because they're telling you these terms characterize a force. What did the other question ask? What terms characterize a force? So you use these 3. Okay. We all know that direction, let's start with direction because it's the easiest. Direction is a geometric ray. What they mean by geometric ray is like this, okay? In geometry we use lines or whatever. So a line, which is the same thing as this, okay? So direction is a geometric ray, okay? Now magnitude. Magnitudes are numbers. What other answer here has numbers in it? This one, it says a non-negative. It cannot be negative. How can you have a negative magnitude? How will the thing move, the object that you're exerting a force on, move if you have a negative magnitude? So you can't have the negative magnitude. So it's non-negative real number. Point of application. Point, that can help you. Or point of application. In normal lives, when you touch something, the point where you touch these two things, something with your hand, it's between your hand and the thing you're touching. So it's the point of application. So that's that. Okay, this is the same question as that other question. And if you also didn't remember it, you remember the last question. The last questions told you characterizing what these terms are used to characterize a force. Okay, so the only ones they gave you were magnitude, direction, and application. They didn't give you the category, nor did they give you speed. So it's only those 3. Okay. Direction. They're showing you arrows pointing this way. So this is left and this is right. If you didn't know, you can use your hands, use your thumb and the one beside your thumb. Keep them open. You can see on your left hand there's a L forming, and on your right hand there's no L, okay? So the left hand is L and the right hand is across L. So your left hand is left, okay? I don't know why I'm saying this, but if you didn't know, I don't know how you wouldn't know, but if you didn't, just know. Magnitude, they already show you the magnitude here. They're telling you it's 5 newtons, so 5 newtons. Point of application, we said point of application is where you're the force acts, okay? So here it's between these two, wait, these two here, okay? I did a mistake in this once in AMS because it looks like it's touching the edge, okay? But I don't know what common sense they have. Apparently to them that's not the edge and that's the middle of the ruler, so it's middle. Okay, and that's 3.4. Now let's go to 3.5. Most of these we had them already in the last physics periodic of term 2, so you should know most of them, okay? They're asking right, and like I taught you last question, left, right, you can check your fingers by doing them if you don't know what left and right is. So this side is right and this side is left. What they're asking for right, so this is the right. This is going up, this is going down. Question number 2. Okay, here, this one, they're telling you that this is 1 Newton directed to the left, okay? They want 2 newtons directed up. The only ones we have directing up are this one and this one. And this one looks more likely to this, okay? So that means this is 1 Newton. So this is 1 Newton. They want 2 newtons, so it has to be a bit bigger than this because this is 1 Newton. So this is your answer 3. This is literally the same question that we had in 3.3, I think. 1, you double it. 1, you double it, you get 2. So 5, you double it, you get 10. And that's your answer. And that's 3.5, I think. Yeah, 5. Done. Let's go to 3.6. Okay, 3.6 is on the tricky side for this question, okay? Because we're talking about magnitudes and angles and stuff like that, horizontal, vertical, whatever. But we know this because we had the exam on it. So you should know this. Okay, so they always have you have 2. You should have 2 if you want to find the angle between. So you should have one going up, one going right, or the opposite direction, okay? So here we have opposite forces going up and down, so we have to cancel this first, okay? So 19 minus 3 equals 16. So this force, we cancel this one and we put 16 newtons to upwards because 19 is greater than 3, okay? So this is 16 newtons, okay? Magnitude, because we have 2 different values going up and down, up and to the right, you can't cancel them because they're like in different, very, very different directions. Like up and down, because they're opposite directions, you can cancel one of them out. But up and to the right, they're completely different, so you can't cancel them out, okay? Magnitude, they want this angle. Okay, first, I'm pretty sure your teachers taught you this, that you have to change it. If it's going like this, you have to change it to go like this, okay? And they want, and then this, you have to create a right triangle. They want here, let's call it F, okay? This is 16 and this is 12, okay? They want F. Pythagoras theorem, this is the hypotenuse. So F equals radical 12 squared plus 16 squared. Open your calculators. We'll do radical 12 squared plus 16 squared. You get 20, and that's your answer here. Okay, and then the angle between, they mean this because it's between this fragment and this fragment, okay? So they want this angle. We can use the tangent rule, okay? So opposite over adjacent. We know this is 16, the opposite is 16, and the adjacent is 12, okay? So opposite over adjacent, so 16 over 12, shift tan tangent. Okay, do it on your calculator. You do shift tan 16 over 12. You get 53.1300, and they want it to their nearest integer, so 53, because when you round you get 53. And that's that question. Okay, you remember the diagram I drew last question? The one where it was like this? Wait. It was like this, and we had to change it and draw it like this. Okay, it's because we have to have, this is the head. Okay, this is head. Okay, and this is the tail. Okay, if you didn't know, you should know. And remember, the head is the extremities. There was one question in the last periodic that asked, what is the extremity of something? It's always head, because head is, it keeps on going, because the arrow keeps on going that way, so it's head. Okay, we need to have, this is the head and that's the tail. Okay, we need to have tail on head always. Okay, so we need to have our diagram looking like this. This should be the head. Oh wait, sorry. It should be like this. Okay. This is the head. This here is the tail. And here it's also the head. You guys understand my handwriting, it's because pens are disgusting nowadays. So we need to always have a diagram looking like this. The head has to be touching the tail. You can't have two heads or two tails together, okay? So let's analyze the diagrams here. Here we have two tails touching each other and two heads touching each other. So this is automatically wrong. Here, we only care about the right angle, to be honest. So just forget the other angle. We only care about the right angle. This is two tails, so they're strong. Here, the right angle is here, okay? And here we have one head and one tail, so that's automatically right. And then here we have, like I said, this is because they didn't change it. But if you change it and put it to the other side, you'll have this and this going like this, so it's like this, okay? So you'll have the head on the tail, so this is right. But on this diagram, this one here, if you change this here, you'll get like this, okay? But here you'll have, okay, another point I forgot to tell you about. We only care about the right angle being different, okay? The other angles should be the same, like, thing, okay? So the same here we have, here the same, and here the same, okay? So if we put this angle here, okay, this will be, the right angle will be right. But then here we'll have a head and a tail, and here we'll have a head and a tail, so it will be wrong, okay? I'm not trying to complicate things, but this is what you have to remember for questions like these, okay? Question 3. Okay, in this question, they told us each square represents 5 newtons, okay? So they want us to find the net force acting on A, okay? So let's analyze the squares, okay? Wait, let me zoom in. Okay, so F1 is going 1 and 2 from A. We're talking about A here, okay? So it's 2. So it's 2 times 5, because we know that each square is 5 newtons. So it's 10 newtons. Don't forget to write units in the written part. So, and then F2, it goes 1, 2, 3. So 3 times 5, which is 15 newtons. And then F3 is 1, 2, 3, 4, 5, 6. So 6 times 5, which is 30. Yeah, newtons. Okay, so we know F2 and F3 are acting in the same direction. Okay, and F1 is acting in the opposite direction. Okay, so we have to add F1 and F2 up. So 30 plus 15 equals 35. And then we have to minus them from F1 because it's acting in the opposite direction. So, no, sorry, this is 45. It's not 35, 45, okay? So we have to minus F1. So, 45 minus 10 equals 35 newtons. And our answer here is 35 newtons. Okay, like I said, we have to draw the diagram to be head on tail and tail, tail. Okay, so head on a tail, and then here is a head, and then here is a tail. Okay, we know F2 is 7.5, so this is 7.5, and then this is 10. Okay, we draw a line here. Okay, this will be our hypotenuse, and this will be the net force or the resultant force. Okay, so Pythagoras theorem, so F net whatever is equal to 7.5 squared plus 10 squared. Let's do it on our calculators. So 7.5 squared plus 10 squared equals 25 over 2, which is 12.5, and here it's 12.5. That's that. Now they want the angle between the resultant and the horizontal. Okay, let's draw our diagram again. Okay, here's 7.5, here's 10, and we found that this, which is the net force, which is the resultant force, is 12.5. We don't really care about that for now, but let's just draw it on our diagram. They want the angle between this. This is the resultant, and the horizontal is this. Okay, so this is the angle in between. So we know tangent is opposite over adjacent. This is up, and this is adjacent. Okay, so shift tangent equals 7.5 over 10. Let's do it on our calculators. Shift tan 7.5 over 10 equals 36.8, which is rounded up 37. That's that question. Okay, this is pretty easy. These are in the same direction. These two are in the same direction. This is opposite, so we have to add these up and then minus it from this, or minus this from that. Okay, so 4 plus 2 is 6. So 4 plus 2 equals 6, and then we minus 8 from 6 from 8, which is 2, and that's that. And 8 is greater than 6, so it's going in the direction of 8 newtons, which is the right direction. That's that question. Okay, last question. This is pretty easy because this is the same concept as the last one. They're going in the same direction. Same. Oh my god, the pen. This should be called the series where Jana hates her pen. So 15 newtons because 10 plus 5, they're in the same direction. So it's 15 newtons. These are in opposite directions. So we minus them. Yeah, pay attention to the arrow where it's going, okay? So we minus them. 10 minus 5 is 5. Simple math. Okay, then these, like I said, pay attention to the arrows. These both are going in the same direction, and this is going in the opposite. So we add 10 plus 5, which is 15, and then minus 20 minus 15 equals 5. So 5 newtons, and they're asking, if they ask what direction is it going into, you pick the greater arrow with the greater force, and you see where that arrow is going. And for this question, it's going to the right, so it's 5 newtons to the right if they ask for the direction of the force. And that's 3.1, 3.2, 3.3, 3.4, 3.5, 3.6 done for the course revision of physics. Thank you.